Hello to everyone in my experimental chemistry class. This video here that you're going to be watching is going to be talking about the relationship between protons, neutrons, and electrons in the periodic table. It's very similar to what we did in last class, although now what we're going to focus on is what if you have what we call ions. Ions are when you take your normal atom, a neutrally charged atom, and you either add electrons or take away electrons, giving the overall atom a net charge that's not neutral anymore. Let me start with an example here. So let's say we took an atom of sodium, and this will help if you do have your periodic table handy. So if you don't have it handy, you might want to pause this, go get a periodic table out, and then just kind of follow along. All right, so if you look at your periodic table and you look at sodium, I'm just going to write down some of the information about sodium that you can find. Sodium is atomic number 11, and it has an atomic mass of 22.99. We're going to round that to 23. So we have our mass, and we have our atomic number. And normally, if I were to ask you for a typical neutral atom of sodium, how many protons, neutrons, and electrons you would say, well, the number of protons would be equal to the atomic number, or 11. The number of electrons that you would have, if it's a neutral atom, would also be 11 because the positive from the protons has to equal the negative from the electrons to give a net neutral charge. You could also find the number of neutrons simply by taking the mass, 23, minus the number of protons, 11, to give us 12 neutrons, neutrally charged neutrons. And that's your typical, that's what we were doing last class. We were figuring out the protons, neutrons, and electrons for a typical neutral atom. Well, let's take a look at what happens with sodium. Now, sodium, if you look at where it is on the periodic table, you're going to see that the most common charge that sodium takes on is a +1 charge. And so let's think about what has to happen to give it a net +1 charge. Instead of ending up neutral, we want to end up with sodium with a net +1 charge. One of the things is if it is sodium, we know that the atomic number defines the element. That doesn't change, and we know that the atomic number is always equal to the number of protons. So if we're going to keep this material as sodium and not change it to a different element, we have to keep the number of protons at 11. We can't change that if we want sodium. What we are allowed to do in chemistry, and in fact this is what chemistry is really an awful lot about, we can change the number of electrons that that atom will have. We can either add electrons or take away electrons. Well, if we want to end up with a net +1 charge, and that's what charge sodium usually will take on when it chemically reacts, we got to think about this for a minute. Let's say we added an electron. If we change that to 12, we would then have 11 positive charges, 12 negative charges. That doesn't match up to be neutral, but that would give an extra electron. That would be an extra negative charge. That's not what we want, because we want a net positive one, not a net negative one. So instead of adding an electron, the other option is we could take away an electron. Instead of having 11 electrons, what if sodium only had 10? Now you've got 10 negative charges. You still have the original 11 positive, and I hope you can see that if you have 11 positive with 10 negative, that gives you a net +1 charge. And so if I were filling in a chart for this particular element, I would say, well, sodium +1 has 11 protons, 10 electrons, and it does not have any effect whatsoever on the neutrons. So you would still have your 12 neutrons, because the neutrons does not change the charge at all. And so that's how you do this. Let's take a look at another one or two of these just to see how this works. I'm going to move to a new slide. Okay, so on this new slide, let's look at a different one. Let's say we had chlorine with a -1 charge. Chlorine normally takes on a -1 charge. So if I were trying to identify the number of protons, neutrons, and electrons, first thing I'm going to do is look at my periodic table. This has an atomic number of 17, and then it has a mass for chlorine. It's 35.4527. We're going to go ahead, since it's 35.4527, and we're going to round to the nearest whole number. We have to kind of go with the 35.4, and we're going to round that to just 35. So its atomic mass, we're going to say, is 35. All right, so that was the information we got from the periodic table. Now let's try to figure out the number of protons, electrons, and neutrons. The protons, as we've always said, protons is always going to equal the atomic number. So it's going to be 17. The number of neutrons will be the mass, 35, minus the number of protons, 17. And so if you were to do 35 minus 17, you'd end up with, what is that, 18. So you'd have 18 neutrons. And now we just have to deal with the electrons. Now normally, if this were neutral chlorine, you would have 17 because the protons and electrons would be the same. But we don't have that here because we want the chlorine with a -1 charge. In order to have a net -1 charge, remember the protons are giving positive, the electrons are giving negative. We don't want equal numbers of them, that would be neutral. We want an extra electron because the electron is giving the negative charge. So instead of 17, if we had 18. Now you've got 17 positive charges, 18 negative charges. That gives you an overall net -1 charge because of that extra electron. That's how you do this. I'm going to give you one more. I'm going to show you one more. I've shown you to get a +1 charge. I've shown you to get a -1 charge. Let's deal with a charge of, let's say, a -3 charge. Let's look at, let's say, nitrogen. So let's say you had nitrogen with a -3 charge. Now again, the atomic number from the periodic table, atomic number of nitrogen is equal to 7. Its atomic mass from the periodic table, if I round it to the nearest whole number, is equal to 14. And if I were trying to identify the protons, neutrons, and electrons, protons, neutrons, electrons, the number of protons always equal to the atomic number. There would be 7 of them. The number of neutrons, we take the mass, 14, minus the number of protons, 7, gives me 7. Now normally if this had been neutral nitrogen, there would be 7 electrons. But we don't have that here because we want to end up with a net -3 charge. Since the electrons give the negative, the protons give the positive, we can't change the protons. In order to end up with a net -3 charge, I think you probably figure out we would need 10 electrons. 10 electrons with 7 protons gives a net -3 charge because of those 3 extra negative electrons. So that's how you do this. That's how you would figure out with these particular things. We call atoms that are not neutral, we call them ions. And we're going to talk more about ions this year. We're going to talk about them a lot. But for now, just realize if I start mentioning in class, solve this for this ion, I'm just dealing with an atom that has a charge. And usually these charges, you can figure out what they should be just by looking at the periodic table. Which column are they in? And I hope this video helps. You're going to get a practice assessment that has some of these problems on it. But they'll probably also include some information from the next video that I'm going to make as well. I hope this helped, and good luck with this. If you do have any questions, just kind of jot them down or think about them, and then when I get back to class, next class on Wednesday, I believe it is, just let me know. Thanks. Bye-bye.